Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. In the previous two videos, we looked at what a clustered index was and what a non-clustered index was. In this video, we're going to take a little step more and look at what is a composite index and how to create a composite index. And then we're going to look into some of the advantages of creating indexes and how to retrieve data fast. So let's continue. One thing before we continue is that obviously every time we create an index, we want to know what tables have indexes already created and what tables do not. And there are two ways to do this. One is through the GUI and one is through the SPROC or the store procedure. In this example, you'll notice that the SPROC that allows me to see all the indexes is as follows, which is sp_help index followed by the table name. And so if you look at this, and I'm going to highlight this, and I'm going to AdventureWorks 2014. So if I execute this, you'll see immediately that I have the index name for that table, the index description, whether it's a clustered index or a non-clustered index or unique and so on, and then the keys or the columns that were indexed. So that's one way of quickly looking at which tables have indexes. The other way obviously is through a GUI. So we can go to AdventureWorks 2012, tables, look at the human resource department, expand that, and then obviously if you expand the indexes, which I already have, you'll see the same thing as we see here. So this is a quick SPROC to clearly understand and be familiar with. So it allows you to see all the indexes for that table. So now let's continue and create a composite index, which again I said is two or more columns specified in either a clustered index or a non-clustered index. So in this case, I'm going to collapse this. I'm going to go back to SQL2, tables, the peoples. Now remember, this table has 50 million rows, and I'm going to go to index and refresh it just to see that we don't have any index created. So now I'm going to use a composite, create a composite index. Now, the composite index is same. The syntax is the same. The only difference is now is I'm using two or more columns. And in this case, obviously, I'm using last name and then first name. So the script is create non-clustered or clustered index, index name, and obviously I've chosen to name it L name, F name to make it clear as to what table and what columns I'm going to be using a composite index on. And then obviously on the table, followed by the two columns. Now a couple of things, look at these notes. The more columns you choose to index, the longer it takes to create an index. So remember, we've talked about what a non-clustered index is, and that is a separate object from the table. It does not sort the columns that you're clustering. It only creates a separate entity for that column. So this is an important concept to understand because space issue becomes an issue. And the larger the table, the larger the index is going to create. So if you have a table now, obviously this table has 50 million records, and we're going to create a clustered index, a composite index, on two columns. One is last name, one is first name. As such, when you create this, it's going to create a separate entity on those two columns with 50 million rows also. And then it's going to have pointers or page numbers illustrating last name and first name. And I'll show you that physically in a second. So let me start this and create it. Now this is going to take about 4 minutes to create, because it has to recreate a separate entity from the table. And as we said, the table itself, the columns last name and first names, don't get shuffled, but a separate entity has been created. Now let's look at that physical entity. While this is being created, let me go to illustration. If you create this, there'll be a separate entity, which is the back of the index page. And let's just illustrate this as a back of the page, this page. So what it's going to do is it's going to take the last, in this case I'm only giving you an example of last name, but because we use the composite, there'd be another column here called first name. But for illustrative purposes, this is fine. So a separate index on table people, column last name. And what it's doing is it's creating a separate entity as this index page is illustrating. This is an Excel, but you can look at it as an index. It's taking the last name and it's rearranging it alphabetically. And then at the same time, it's got pointers to the raw data of the table with page numbers, if you will, or as an analogy to the page number. So now one of the queries that we're going to be executing is looking for all the last names with Franklin 600. And what the query is going to do when you run it, rather than go to the table which is unsorted in the last name, it's going to go to the index in the back of the book. It's going to go all the way, quickly go down to Franklin. And then once it finds Franklin, because it's already organized, it's going to be a lot faster to find Franklin. It's going to have a pointer which says, hey, go to this page on the data and then retrieve the data. And this is going to be extremely fast. So this is what it's doing. It's creating a separate entity, and this is why I've illustrated this. And obviously this is going to be the result set once we execute it. So important to understand that when you're creating a non-clustered index, even a composite index, that you're creating a separate physical pages for each thing. The other thing to note is that when we're talking about non-clustered indexes, because it's creating a separate object or separate entity, each time this index, or the table I should say, each time the table is updated or deleted or has an insert, this has to be correspondingly updated also. And let me illustrate that here. So this is the index that we've been looking at, and we're looking at the Franklin. Now remember, note Franklin is in slot 11 in this particular example. Suppose I delete Franklin. If I delete this column right here, and this is the table, so this is the table, and if I delete a table here, what's going to happen to the index? Well, you can see I've already deleted this, and this is the result set of the index. We do no longer have the Franklin in index, and as such, the name numbers here have been reshuffled. Franklin here before deletion was slot 11, and now I don't have it here, and 11 has become staple. So now we're going to have to refresh this and update this index table to reflect the new data. So this is why it's very careful. You should be careful in designing indexes. But I'm going to go into the designing and why and when, where a little more later. But this is just to illustrate that anytime you modify the data itself, the index itself has been modified accordingly. So let's go back to the SQL and see if it's been. So it's going to be almost done. It took me about 4 minutes to do, but I want you to illustrate this, that it does take a long time. So when you're deciding on what to create, obviously the quantity matters and the frequency of this scripts matter in the where clause. And we'll be discussing that in a second. So it should be almost finished, and there we go. So now if I go here, let me look at it. It took 4 minutes. Obviously I want to see the index that I just created. So it's, remember, SP_help index followed by the table name, in this case people, and we're on the right database. So if I execute this, you can see that the index I just created. Now one thing I want to do now is I'm going to actually, let me look at it here. I'm actually going to now drop this index that I just created. I'm going to use this, I'm going to drop it, and it's dropped. And if I go here and refresh, you'll see that it's been dropped. And the reason I want to drop it now is because I'm going to have to recreate it and illustrate to you the next point, which is right here. So now we've understood what a composite index is, how long it takes, what columns to choose, and so on. So now that we've understood what a clustered index is, a non-clustered index is, and a composite index is, what we're going to right now do is actually look at the data and see the benefits or non-benefits of creating a clustered index. So here in this example, if you look at it, let's start. So at this moment, SQL database with people table, 50 million rows, does not have a cluster of any type. Now, in this example that I'm going to give you, I'm going to run a query without an index, looking for the last name Franklin 600. As there is no index on the last name, the query will have to start from the first row and sequentially go through all the 50 million rows until it finds the last name Franklin 600. So that's going to, now this is called a table scan. And this is extremely poor for performance. And we've illustrated that physically in that I've asked you to, if I ask you to open a book that has 1,000 pages and I want you to find the word cantaloupe, obviously what you have to do is go through the first page, the first line, read each line until you get through to the word cantaloupe. And it's, you're going to have to literally go through the entire pages and every page and every line to find that word cantaloupe. Even if you find that word cantaloupe on page 30, that does not mean that you've retrieved all the words with cantaloupe. So you're going to have to continue and finish the entire book. And in nomenclature of SQL, that's called a table scan. You're going through each row by row in a table trying to find that word cantaloupe. So obviously now there has 50 million. So what I'm going to do now is just run actually this select statement. Now the select statement is select all from people where last name equals Franklin 6. And remember, this does not have a index in the beginning. So it's going to have to do a table scan. It's going to have to go through the field 50 million rows one by one, trying to find all the data. So now if I execute this and run it, it says obviously in my previous example, it took about 40 seconds to retrieve 12 rows before creating an index on last name. So now you're seeing an illustration of the importance of creating an index. Now we have to be judicial in our creation of indexes, because a lot of creation of indexes can hurt performance. Because remember what I said, when you create non-clustered indexes, you're creating extra space and extra resources that are being utilized to create this separate entity. And at the same time, when you update or delete the table, this has to be updated also. So it's not always beneficial to see, and we'll determine what is. So here's the result set, and as I said, we've got 12 rows. So that took 12 seconds to retrieve all the information for last name Franklin 600. So now what I'm going to do is, I'm going to create an index on last name. To create an index on the last name column, the data has to be sorted and has pointers to the actual data in a table. The creation of an index can take a long time because it's copying the column's last name separately with pointers to data. It's doing this. It's recreating this at the same time as I've mentioned. Anytime you update the table people with an insert, update, or a delete, the index on that column has to be updated also to reflect what's the proper sequence in a table. And I illustrated that right here, that if you do something here, or if you do something on the table, then this has to be updated also to reflect the new index. So let's look at that now. So remember, it took 12 seconds to retrieve, it took 35 seconds to retrieve 12 rows for Franklin last name. Now I'm going to create an index. So this is just a simple index creation, but again, it is going to take a few minutes to create an index because it has to recreate that entire column and pointers. So while that's going on, let's just look at a couple of things here. Let me look at here. Oops, wrong one. So let me look at this. So remember now, just to understand that when you create a non-clustered index, you're creating an index similar to that in the back of a book, and you have extra pages. Those extra pages is referred to in SQL parlance as disk consumption of disk space. It requires more space because we're adding more pages to the end of the book. So this is a non-clustered index example. Here, the modern book here, obviously this is a phone book, and this is an example of a clustered index, because all you're doing is taking the columns that you've determined to be clustered and organize them in an alphabetized manner. And you can only have one clustered index per thing. So this is an example of a yellow pages. So that's an easy way visually to understand the differences when you're trying to understand what clustered index is and non-clustered index is. So let's look at see how we're doing here. And 1 minute 20 seconds, so it's still going. And as I said, it took about 3 minutes. So now you understand the importance of creating non-clustered indexes. Now, the other question you can have is, hey, if indexes help retrieve data fast, why not create indexes for all the tables? Well, one of the obvious reasons, as we've been talking about, is that you're going to need extra space. And if this is a 50 gig space, you're going to need approximately 50 gigs of data to 50 gigs of space to compensate. Now you've doubled your space. So that's another thing. The other, obviously, performance issues when we talk about it deeply in coming videos is that not all tables need to be indexed. And I'll be showing you why and when and where and how you should be creating indexes on specific tables. The primary purpose of indexes, as I mentioned, is to retrieve data fast. Rather than going through the entire book or to the table in an analogous sense, you go back to the index in the back of the book, look at the page number, and go immediately to the page number, and that's a lot faster than scanning the entire book, which is a table scan. So we don't want to do that. So this is almost done, and then we'll be ending this session. But the important thing to remember here is that it took 35 seconds to retrieve 12 rows, and it did a table scan, meaning it went through the entire 50 million rows trying to find relevant information to last name Franklin. Now that we've created a non-clustered index on the last name, and it's organized and it's sequential, meaning it's organized like this and it's sequential, let's see how long it takes to retrieve that same data. So now I'm going to do exactly the same thing. I'm going to retrieve the data for Franklin. Let me uncomment this and comment this out. So let's see how long it takes to retrieve that same data. And if I execute this, it took 35 seconds. And now it took less than a second. It's not even registered. That's how fast it was. So rather than doing a table scan up and down the entire table, it went to the index. It went directly here. It said, give me everything that's in Franklin. And then it had a pointer to that data and a page number, and it retrieved that data extremely fast. So that's how you can see the advantages here. And we can certainly do that for another. Now that we've created a cluster in it, we can certainly do that for other data, not necessarily that one. So how long will it take to retrieve everything for Everett? Virtually instantaneous. And in this case, 17 rows. So now you see the advantages of creating a non-cluster index or a cluster index on specific tables. And we'll be talking about when, where, how in the next coming videos. But I think I'm going to leave it here. So I hope I've clarified the importance of cluster index, non-clustered index, composite index, and the benefit of having them. In the next coming videos, I'm going to be showing you what not to index and when to index. So that'll be an important subject matter. So I'm going to leave it here. And my name is Rafael, and this is how to become a production SQL database administrator.